Welcome to CH225 course on Statistical Data Analysis for Chemists. I am your instructor, Anil Kumar. These are my contact details. This is video 24 in this series. In this video, we will learn about standard error in the estimation of the mean. This is also one of the important concepts in data analysis, and hence, please pay attention to make sure you understand it completely. Before we proceed any further, let us have a quick review of what we learned in the last video on sampling distribution of the mean. This is the table which we prepared for the expected value and the variance of the sample mean when the sample size was increased. This is for the population of bag full of equal numbers of billiard balls, marked with number 1 and 2. We learned that the expected value of the sample mean does not change with sample size. Furthermore, the expected value of the sample mean is the same as population mean. Therefore, it is possible to use the sample mean to predict the population mean using distribution of the sample means approach. In other words, sample mean becomes the estimator of the population mean. This was our first step towards prediction of population parameter using sample parameter. Therefore, this was our first step in inferential statistics. We learned how to predict population mean using sample mean. Therefore, sample mean is the estimator of the population mean. The method we learned in previous video is based on the analysis of many samples. We have to calculate the expected value of the sample mean. The prediction of the population mean is highly reliable using this approach. However, the major issue with this approach is the high cost, due to study of many random samples. Therefore, it will be advantageous if we can predict the population mean using single sample mean. This is the approach we will learn in this video. Though it is possible to predict the population mean using sample mean, it has some error in prediction, and this error is called standard error in estimation of mean. Let us learn this approach now. Let us have another look at the same table to find out what else can we extract from this table. Look at the sample variance and compare it with the population variance. Two things are obvious. First is that the sample variance decreases with increasing sample size. Second is, when we compare the sample variance with the population variance, we can say that sample variance scales with respect to the population variance by a factor of 1 by sample size. We can confirm it as the sample variance for the sample size 3 is 1 by 12, which is population variance divided by 3. Therefore, we conclude that variance of the sampling distribution of the mean decreases as sample size increases. It decreases by a factor of 1 by sample size. This picture explains the narrowing of the distribution as sample size increases, while the expected value remains constant. Now, what does this decrease in sample variance with sample size mean in terms of its physical significance? Think about it. Let me give you a hint. Square root of the sample variance is standard deviation, and standard deviation is directly related to the width of a distribution. Therefore, the standard deviation will be population standard deviation divided by square root of the sample size. So the physical significance of decreasing spread with increasing sample size signifies that your sample mean will become closer and closer to the population mean. This is shown here, wherein the range where sample mean can be found decreases as sample size increases. Here is another way of showing the decrease in gap between sample mean and population mean with increasing sample size. The vertical dashed line is the population mean. The double-headed red arrow shows the range in which one can find a sample mean when the sample size increases. This information is very useful when we are going to predict population mean using a single sample. Higher the sample size, closer is the sample mean to the population mean. Hence, the ratio of the population standard deviation to the square root of the sample size is a direct measure of the gap between your sample and population mean. Therefore, this is also called the standard error in estimation of the population mean. Now it is very clear that it is possible to predict the population mean using single sample mean. However, the gap, or the error, between the predicted and actual mean decreases as sample size increases. This gap is called the standard error of estimation of the mean, and can be quantified if sample size and population standard deviation is known. Now, take a hypothetical situation to think what happens if your sample size becomes infinite. If our sample size, or n, becomes infinite, the standard error of estimation will become 0. Which means your sample average equals population average. This is not surprising, as sample of infinite size is nothing but the population. This means there is only one sample possible, and hence there is no probability distribution and hence no error in prediction. Therefore, you are averaging the full population, and hence it has to give population mean. Therefore, our calculations are consistent with respect to sample size. Let us now summarize what we have learned in this video. We learned that it is possible to predict the population mean using single sample. In order to do so, we again use sample mean as an estimator of the population mean. We also learned what is standard error in estimation of means and how to calculate it if population standard deviation and sample size is known. Standard error of estimation of population mean decreases as sample size increases.